Consecutive digits. All right, here we go. We're going to write the function has consecutive digits that takes a possibly negative int value n and returns true if the number contains two consecutive digits that are the same and false otherwise. Let's actually look at the test cases to make sure we understand what we're being asked. And we have has consecutive digits. Here we go. So this one false, this one false. Even though 1 and 2 come after each other, that's not what the question is asking. You see, this is true because 1 and 1 are two consecutive digits that are the same. In this case, 3 and 3, two consecutive that are the same. Here, even though 1 and 1 are both in the number, they're not consecutive. There's a 2 between them, hence false. Okay, now that we understand the problem, if we're to run our code, we realize that our test function is testing still for digit count. So let's go down here to the test function. Let's turn off digit count and turn on consecutive digits. So now we fail because, of course, 42. Well, yeah, okay, we fail because of this. We haven't written it. For those of you who are wondering, by the way, why 42, you should be wondering that. And you turn the number 42, and you'd go to Wikipedia. And in Wikipedia, you would find out from the Hitchhiker's Guide to the Galaxy that this is worth reading on your own time. But this is why. It's partly why. Actually, the deal is we needed a number that represented the fact that we haven't written this code. So when you see return 42, you know that just basically means you need to write this. And 42 is a nice number to use because of the Hitchhiker's Guide reference. That's all. Okay, so has consecutive digits event. So first, to tell if a number has consecutive digits, we're going to have to walk through all the digits in that number. But we know how to do that. We just did it. So while n is positive, the ones digit is n mod 10, and then we'll move n over by one digit. Okay? So this is the basic pattern for walking digit by digit through a number. And now what we want to do is we want to keep track of the previous digit and compare it to the current digit. So right here, we could say if the previous digit is the same as the current digit, then it has consecutive digits. So we would return true. If that's not the case, we will remember that the current digit is now the previous digit for the next time we go around the loop. And in this way, we keep moving along comparing the digit to the one before. The thing is, you have to start this process. What's the first previous digit? Well, you have to set it before the loop. You have to set it to a value that can't possibly match the first digit. Let's just do -1. No digit will be -1, so we know that the first digit won't match, but what the first step does is loads up the previous digit. Great. Now, if we make it all the way through the loop, and we never found a match, then indeed, there are no consecutive digits. This is close to correct, and we run it. We didn't pass. And, the negative case, we know what to do about that. N is ABS of n, and there you have it. All functions pass. And that is a candidate solution for has consecutive digits.